We'll go ahead and get started. So today's pre-lab is up here. So you guys are going to be actually doing a chemical reaction using the Bunsen burner, and I'll show you, kind of walk you through it here in a minute. But we've been talking about matter is made up of atoms, okay? Cute little atoms, oh, makes me smile. And all matter has mass and occupies space because atoms have mass and occupy space. Let's see, is that what I want? Yeah, I'll try that. Matter can either be a pure substance or a mixture, and if it's a mixture, it's homogeneous or heterogeneous. That's not as much as what today we're going to be focusing on. Matter can be either an element or a compound. And we said that you can go back and forth from elements can be built up into compounds by chemical reaction, and compounds can be broken back down into their individual atoms or elements by a chemical reaction. So today, the chemical reaction you're doing is you're taking two elements, solid magnesium in its ribbon form, and you're combining it with the oxygen from the air, of course, oxygen gas. And we're going to be talking more about chemical reactions, but we use a reaction arrow to kind of show what you start with, separated from what you end with. So today, you guys are actually going to apply heat, and you're going to make your magnesium combine with oxygen from the room. So we say what you start with are your reactants and what you end with are your products. So that MgO is written as it really is. We know that one magnesium will combine with one oxygen to form what we call magnesium oxide. Now you guys actually are ultimately going to confirm that you get a 1-to-1 ratio. That's kind of the crux, the coup de grace of your lab today, okay? So I'll kind of talk you through that when the time comes, but that's your product that's being formed. So today you're going to be using, this is my rendition of a crucible, okay? It's one of the two things you have in your drawer, or three things if you count the crucible lid. That's those white things that are made from porcelain. So you're going to be putting your magnesium ribbon, I've got it, the strips already kind of cut for about 0.3. You're going to be weighing it before you, ultimately weighing it before you start. We'll talk about that here in a minute. But you're going to heat it up. So this all came at once, didn't it? So these things are my oxygen atoms from molecules combining with your magnesium to form, this over here is your product. This will kind of look like ash. This is your magnesium oxide. So bottom line is you have a mass here, you have a mass here, and then actually by difference, you're going to get the mass of your oxygen. So bottom line is what is in your crucible to start with, just plain old magnesium. What's in your crucible to end with is magnesium with oxygen. So it's going to be heavier. And so you're going to get the mass of the oxygen by difference. So let's see. What else did I want to say? So these are on your data sheets. I think up there is just what I want to emphasize. So kind of in this box is kind of what we're emphasizing today. We've been doing what we call, you guys have been doing, a mass to moles conversion. So, for instance, this first check mark up here, get the moles of magnesium. Get the moles of magnesium. Well, you have about 0.3, and we can use the molar mass of magnesium, I love that phrase, from the periodic table to get from grams to moles. You're going to have to go get the moles of oxygen that was added. How are you going to do that? You're going to use the molar mass of oxygen from the periodic table. And you got the mass of the oxygen by difference. This here in green is actually kind of your last little box that you're going to fill in. Do you have a 1 mole to 1 mole? Do you have like the same moles of magnesium that you started with, the moles of oxygen that were added? So that's kind of what we're after. We're verifying the formula of magnesium oxide, basically. Okay. All right.